Hello students, today we will be discussing about mole concept. This is basically the first part of basic principles of chemistry. The understanding of this chapter or this topic will be restricted to the type of questions asked in medical entrance examinations. So first we will study what is mole. Mole is defined as an unit which will signify a certain number of particles of any substance. So what is that number of particles? That number of particles is Avogadro's number. So if we know that there is 1 mole of any substance, it will be Avogadro's number of particles of that substance. What does it mean? Let us go into it. So first, let us see 1 mole of O2. What does it mean? 1 mole of O, what does it mean? And 1 mole of oxygen, what does it mean? If it is 1 mole of O2, this is one oxygen molecule, we all know. So 1 mole of O2 means, what is 1 mole? 1 mole is Na, that is 6 into 10 to the power 23 O2 molecule, simple. When it comes to 1 mole of O, it is 6 into 10 to the power 23 O atoms. If it is 1 mole of oxygen, what does oxygen means? Whenever it is said that it is oxygen or say nitrogen in normal, it means molecule and not atom, because molecule has independent existence. Atoms does not have independent existence. So when I say oxygen, that essentially means molecule. So in this case, it will be again 6 into 10 to the power 23 O2 molecule. So this is just the instance that I have shown where I have used the concept of Avogadro's number. This concept, this is very important, this concept, Avogadro's number. So now, if I go into some questions that has been asked in examinations previously, then how do I solve them? Suppose somebody asks me number of atoms in 2 mole of N2O. So how will I solve this problem? You just have to notice the steps that are involved in a very conceptual manner so that you don't make mistakes in examinations. That is it. What is 1 mole of N2O means? Suppose when we have discussed about 1 mole of oxygen, it was Avogadro's number into that is Avogadro's number of particles. That's it. But here it is said 2 mole, not 1 mole, right? So we'll come to 2 mole also. So first, for 1 moles means 6 into 10 to the power 23 N2O molecules. It is directly said that 2 mole of N2O. So let us do first for 1 mole of N2O. Now, please do not go into this part first. Whenever there is a mole given, first find out the number of particles like I have given over here. So, here there is 2 moles, so it will be directly 2 into Avogadro's number that is listed over here N2O molecules. Now, one molecule of N2O. Now you can think about these atoms. One molecule of N2O is equal to 2N plus 1O atoms. So total number of atoms is 3. But there are how many molecules that we have got in 2 mole? Total number of molecules 2Na. So total atoms is equal to 2Na into 3, that is 6Na. So now we reach the answer. So the thing is that what we have applied as the concepts. We have applied simple Avogadro's number concept over here and nothing else. So this was our first concept that has to be used while solving the problem of mole concepts. Okay. Now our next thing is that we have listed over here again. 1 mole is equal to molecular weight. So we'll write the same thing over here. Molecular weight I can write MW. Now what does it mean? Suppose it is said 1 mole of O2. It means molecular weight of O2. Just simple. What is molecular of O2? What is the atomic weight of oxygen? So O2 will be 2 into 16. 32. Similarly, if I say you 5 moles of nitrogen. So what does it become? First of all, we have to find 1 mole of N2 is equal to 14 into 2, that is 28 gram. So 5 moles of N2 will be 5 into molecular weight, that is 5 into 28. So it will be 140 grams. Now, in a problem, if it is said find number of atoms in 0.5 gram of mixture, then how will I find it out? So let us do this one and understand the two concepts that we have learned till now. One concept that we have learned is 1 mole is equal to 6 into 10 to the power 23 number of particles, be it molecules, be it atoms. And another concept that we have just learned right now, that is 1 mole will be equal to the molecular weight of that molecule. When we have to express from mole to mass. Suppose it is said that there is 2 mole and what is the weight in grams, then 2 into molecular weight will be weight in So let us go into this problem for the solution. It is said, what is the weight given? 0.5 gram. Now the molecule that we are talking about over here is H2. What is the molecular weight of H2? 2 into 1 is equal to 2. So MW is equal to 2. In concept of moles, it is always desirables, because here what you have to find out, let us see. Here there is a weight given as 0.5 grams and you have to find out the number of atoms. So if I have to find out the number of atoms, that means there is something, a concept of Na or Avogadro's number will come. And when I am talking about this one, so from 0.5 gram I will go to first mole. How many number of moles? Then Avogadro's number. So how to find out the number of moles in these cases? Number of moles is equal to weight in grams by molecular weight. So what is the weight in grams? 0.5 and molecular weight is 2. So it will be 0.25 moles of H2. So 0.25 moles of H2. First we have to find out how many molecules of H2. Then how many molecules it should be? First of all, what is it said? It is said moles is said. So first I write Na. How many moles it is said? 0.25. So I write 0.25 Na. Okay. So I find the molecule. But what it is said? How many number of atoms it is said? We have to calculate the number of atoms. So for atoms, in one molecule of H2, there are 2 atoms. So 0.25 Na into 2 atoms of hydrogen is present. So this is how to calculate the number of atoms. So here we have used both the concept. One concept is we have related the weight given with mole, and then from mole we have counted out how many number of atoms will be there. So we have used two concepts, not one concept anymore. We have used two concepts. Now suppose in the same problem they say find number of electrons. Then how will you find out? Now one hydrogen atom has how many electrons? One electron. So how many hydrogen atom is over here? There is 0.25 Na into 2 H atoms. So number of electrons? Point 0.25 Na into 2 into 1, because there is 1 electron per hydrogen atom. So clear? Now there are certain problems that are asked sometimes in examination, which has the maximum number of molecules, which has the maximum number of atoms. If it goes deep, it may ask you which has the maximum number of protons, which may has the maximum number of neutrons, or in the case electrons. Generally electrons are asked, protons and neutrons are not asked generally, because electrons define chemistry more or less. So in case of maximum number of molecules present, the normal questions that have been asked in medical entrance examinations are based on maximum number of molecules. They don't even go into the atoms part. They generally hover around the molecules only. So now that we have known that how to calculate the number of molecules, now we can easily solve those problems, because there will be four options. Maybe they will say 7 gram of nitrogen, 2 gram of hydrogen, 16 gram of nitrogen dioxide, and 16 gram of oxygen. So in those cases, to first calculate, please do not use this 6 into 10 to the power 23. You write them Na, because if you write time and, because it will be a multiple choice question in your rough work. If you do time and 6 into 10 to the power 23, it is tedious for you, it takes more time, and it is also not useful. So keep the Na part along and compare the other magnitudes that have been multiplied with Na. So if I just compare two things, suppose I take 7 gram of N2 and I take 16 gram of NO2, and somebody asks me, there may be two questions from it. One is which has the most number of molecules. So that is the easier part, to find out the most number of molecules. So how to calculate that? So I know, first of all, I have to go into moles, simple moles, then molecules. So how many moles should be over here? 7 by nitrogen's molecular is 28. So it will be 0.25. Here it is 16 gram. So what is the molecular of nitrogen? For nitrogen dioxide, for nitrogen it is 14, and for O2 it will be 16 to 2, 32. So total will be 46 around. Am I correct? I hope I am. 14 plus 32, yeah, 46. So here I write 46. If I cancel it out, 8 by 23, it will be more or less, how much it can be, 8 by 23. How much it can be 8 by 20, because this type of calculations will be required. Sometimes you have to just assume, you cannot just calculate all the time the exact number. 8 by 24 is 1 by 3, that is 0.33. So it will be in the magnitude of maybe a little more than that, because it's 8 by 23. So as it is not 24, so it will be around maybe 0.34 moles. I'll take 0.34 moles. And so how many number of molecules? So let us see over here how many number of molecules is coming. 0.25 into Na. And here how many number of molecules will be coming? 0.34 into Na. So which is more? It is very clear that the second one is more. So it is very easy now. Now if it is said that which has the maximum number of atoms, in that case this guy will have 0.25 into 2 Na atoms, because one nitrogen molecule, this nitrogen molecule will have 2 atoms, and this one will have 3 atoms. So this will be 0.34 into 3 Na atoms, because 1 N and 2 O2 atoms, O atoms. So in this case also the number of atoms will be also higher in case of nitrogen dioxide. This type of questions has been asked in examination in the tune of 2000 2002. So these are easy questions if you can combine these two concepts that we have already discussed, that is Avogadro's number concept, another is 1 mole is equal to molecular weight. Simple thing. So you just have to remember two things. One is 1 mole is equal to molecular weight, and another thing is 1 mole is equal to Avogadro's number. And always remember number of moles. You have to calculate number of moles from mass, weight, pardon my handwriting, by molecular weight. That's it. Now another important thing, the last concept of the mole concept part that we are discussing today is the volume relationship. Now 1 mole is equal to 22.4 liters or 22400 cc or centimeter cube at 0 degree Celsius, 1 atmospheric pressure. Okay, fine. Now this is the conversion with respect to 1 mole. Until now we have related mole, Avogadro's number and mass. Now we'll relate volume with mole first, and then we may have to combine the all three, that is mole, mass, volume, Avogadro's number. So first of all, what kind of question that can be directly asked from the thing that we have just learned right now? So suppose it is said that is there is 44.8 liters of N2. Again, when we went for mass to particle analysis, what did we do? From mass we have converted to moles. Here the case is volume, nothing else. In case, this is the case of volume. So number of moles, when you have calculated the number of moles, over here we have written weight by molecular weight. Here I write a similar kind of thing, volume by molar volume. What is this molar volume? Molar volume is 22.4 liters at 0 degree Celsius and 1 atmosphere. So this 44.8 liters what I have been given is at STP or NTP. Basically there are two conventions. Sometimes they say STP, standard temperature and pressure. Sometimes they say NTP, normal temperature and pressure. But let us remember it is 0 degree Celsius and 1 atmosphere, where this molar volume of any gas will be 22.4 liters. Why it is called molar volume? Because it is the volume occupied by 1 mole of that gas. Okay, so 44.8 liters. First thing what we will do, in case of weight we have found out the number of moles. So in case of volume we will again find out the number of moles. So 44.8 volume by molar volume, written in the right side, this formula we are using, number of moles divided by molar volume, that is 22.4, cancels out, it becomes 2 moles. Now it becomes 2 moles, fine. Now suppose it is said now find the number of molecules. So it becomes 2 moles, 2 Na(N2) molecule. Now they say find out number of atoms, 2 into Na into 2 N atoms. Now if it is said find out the number of electrons, 2 into Na into 2, one nitrogen atom will have 7 electrons, so into 7 electrons. So we can calculate whole lot of things just if we convert it to the moles. So the concept of mole, again all the problems that is associated with the mole concept have a single trick. The trick is convert it into number of moles and your job is 75% done. Now it is said that now we have calculated the number of particles. That is, we have already related two things. What we have related? We have related volume, mole particle, but we have not yet related the weight. So in case of weight, what I will do, I already know that is 2 mole of N2. If it is said how many grams of N2 is there in 44.8 liters of N2, first I calculate the number of moles. Like here we did. So in case of 2 moles of N2, it is 2 into molecular weight of N2, because 1 mole is equal to the molecular weight, 2 into 28. So it is 56 gram. So now I have connected the mole with weight also. There was a problem once asked in the medical entrance examination in 1988, that is one sorry 1 cc of N2. They have given around 4 options over here, as they give always. One was in terms of atoms, one was in terms of molecules, and one was in terms of electrons, and then all of the above. And they said find out which is the correct answer. Fine. So first, our target is 1 cc. It is said at STP is equal to 1 by 22400, because when I find out the number of moles, how do I find out? Because there it was liters, here it is centimeter cube. For centimeter cube, number of moles, volume by mv, molar volume. So volume is 1 cc. What is molar volume in cc? 22400. So I find out the number of moles first. Then if I first convert it into the number of molecules, then 1 by 22400 into Na, or I write directly 6.02 into 10 to the power 23. So something that is cancel out, 1 by 22.4, I cancel out some zeros from over here. So it becomes 6.02 into 10 to the power 20. Now let me write down the options in the right side. It will be easier for us to understand. Number 1, they have said 1.8 by 224 into 10 to the power 22. Number 2, they have said 6.02 by 22400 into 10 to the power 23. This is molecules. This one was atoms. This one was, number 3 was 1.32 by 224 into 10 to the power 23 electrons, and number 4 was all of above. So first we calculate the number of molecules over here, that is this one. So we have already calculated this part, and this matches with one of the answer over here, that is molecules, they are matching. So this is correct. Basically at this now it's correct, but it may be because there is all of the above, maybe the first one is also correct. So I'll now check what should be the, I don't need this cancellation at this moment. I'll check that what should be the number of atoms. So one molecule of N2O will be having 3 atoms. So 3 into 6.02 into 10 to the power 23 divided by 22400. So what is 3 into 6.0? It will be almost 18 into 10 to the power 23 divided by 22400. So I cancel out some zeros over here again. So it becomes 21. So 18 into 10 to the power 21 divided by 2 to 4. So it becomes 1.8 into 10 to the power 20 divided by 2 to 4. So it matches with the number 1 that has been given. So after that I don't need to calculate, because as two answers are correct, this one and this one, so obviously the last options will be correct, this one. So it will be all of the above. This will match. You can find out the number of electrons over here. Nothing much to worry about. 1.8 into 10 to the power 20 into 1. What is the number of electrons? Now here there is, because I don't want to calculate this because this will take time. As I have done molecules and atoms and that has matched, I will go for all of them. If it wouldn't have matched, I would have gone for electron. But let us do electron for the problem's sake. There are 2n and 1 oxygen. So in 2n there will be 7 into 2, 14 electrons, and in 1 oxygen there will be 8 electrons. So there is total 22 electrons. So I'll just multiply 22 over here and I'll write to 24. So what it comes out to be 1.8 into 22, that is sorry, actually it should not be multiplied with this part because these are number of atoms. So I'll get it from here. So it is 6.02 into 10 to the power 23 divided by 22400 into 22. So now it becomes 22 into 6, it becomes 132, which is okay, into 10 to the power 23, and over here it is 22400. So if I cancel out these two and put a decimal over here, it becomes 1.32 into 10 to the power 23 divided by 220. So this is the way. Now see, in this problem I have used two concepts here, actually three concepts. I have used the volume, converted into moles. From moles I have converted into number of molecules, then number of atoms, and then number of electrons. But in case we are given some mass also, suppose it is said 1 cc of N2, fine. It could have been said that 20 grams of N2. Then also I would have calculated the number of moles first and then gone for the particles. So these are the type of problems that have been asked. So if I go again back to the first part where from we have started with three concepts. 1 mole is equal to molecular weight, 1 mole is equal to 6 into 10 to the power 23 particles, 1 mole is equal to 22.414 liters at NTP. And another two things that we have learnt is number of moles is equal to weight by molecular weight, और एक क्या है, volume by molecular volume. So if I can apply these principles to my problems, then I would be able to solve more or less all the problems related to mole concept given in the examinations. There will be certain other parts also, because I have already divided them into around 9 parts, 9 or 10 parts. So each and every part I will discuss one by one. This was the first part, which was I classify as a mole concept. After this there will be Gay-Lussac's law, where we will learn more about this molar volume, because this molar volume basically came from Gay-Lussac's law. Then we will study about stoichiometry, when this this concept, this mole concept is used in equations, chemical equations, we call that stoichiometry. Then there will be a concept of limiting reactant, there will be equivalent weights, there will be molarity, normality, molality that will come into action. And we will also study about the vapor density, then how the isotopic masses are calculated, and then the total concept of basic principles of chemistry will be understood. Actually, this chapter called Basic Principles of Chemistry sometimes does not have much of a question in the examinations, but it indirectly affects the other chapters, because if we understand, as the name suggests, Basic Principle of Chemistry, if you understand the mole concept well and if you understand its significance, then it is very easy to interpret the other parts of chemistry, and we'll do that in that way only. So this will be our first task, that how to grasp the total basic principles of chemistry in terms of principles and also in terms of how the questions are to be answered in the examinations. Thank you for today. We'll come back to with another topic in another few days. Please let me know that if you have any questions regarding this theory that we have gone through today, and if there is any questions that have been asked in different examination that you know better than me, or you know more than me, because you guys are studying more day out and day in day out, different types of questions, problems. I know that you guys are hardworking, so there will be some problems that falls within this formulas or within these concepts, and if we can solve it together, that will be beneficial to me, beneficial to you guys and everyone. Thank you. This is from Supnit's classes.